Lesson 8, Example 2. In this example, we are asked to decompose this given rational expression. But notice that the denominator has not been factored. So we are going to need to factor it first. So we have a little preliminary work. So if we factor the denominator, remember that you're looking for what does these two terms have in common, and that is x. Then you open up a set of parentheses. What times x will give you x squared? That is x. And what times x will give you negative 4x, and that will be minus 4. So now our first step is to set this up into two fractions, the sum of two fractions, one with a denominator of x and one with a denominator of x minus 4. And we don't know the numerators, so we're going to call this a and b. Now, if you remember from the previous example, the next step is going to be to clear out the fractions. So we're going to multiply both sides by the common denominator. So we're going to multiply the left side by x times x minus 4. And we're going to multiply the right side by x times x minus 4. And think of this over 1, so it's going to cancel with the numerators. So in the first, on the left-hand side, x's will cancel, x minus 4's will cancel, and we're only left with the numerator 3x minus 8. On the right-hand side, however, for this first fraction, only the x cancels. So we have a times x minus 4. And for the second fraction, the x minus 4's cancel, and we're left with bx. Now we need to do a little work to get rid of these parentheses on the right-hand side. So we're going to distribute a. So that's going to give us 3x minus 8 is equal to ax minus 4a plus bx. The next step is to rearrange these. So I'm going to get the terms that have x in it side by side. So that's going to give me 3x minus 8. So I'm still leaving the left-hand side alone. Is equal to ax plus bx minus 4a. So now remember we have that property. We have a polynomial on the left-hand side. We have a polynomial on the right-hand side. And for these to be equal, the coefficients of x have to be equal. So I think I got a little ahead of myself, but that's okay. So we're going to factor x out over here from these two terms, and x times a will give me ax. X times b will give me bx. So now for these two polynomials to be equal, the coefficient of x on the left has to equal the coefficient of x on the right. And the constant term has to equal the constant term. So now I can set up a system of equations. So I'm going to have a plus b has got to equal 3. And negative 4a has got to equal negative 8. Now I think for this system, the best way to solve it is to use substitution. So I'm going to solve this equation for a. So I'm going to divide both sides by negative 4, and that will give me a equals 2. Then I can plug that into this equation to find b. So I'd have 2 plus b equals 3, because a is equal to 2. And now if I subtract 2 from both sides, it's going to give me b equals 1. So now that I know what a and b are equal to, I can plug them into my original decomposition with the known numerators. So 3x minus 8 over x squared minus 4x is equal to a, which is 2, over x, plus b, which is 1 over x minus 4. And that is your final answer. There is one more example in this lesson, but what I would like for you to do is to try this one on your own, and we will discuss it when we return to class. So give it your best try. Look at the examples that we've done and see if you can find the partial fraction decomposition. I will give you one hint. If something is missing, you can represent it with the number 0. Now that might not make much sense to you now, but hopefully once you get down to the polynomials, you'll see what I'm talking about. Good luck, and I hope to see you soon.